Yes, good day everyone. Today we shall be looking into the topic trigonometry and the objectives, our goal, our aim in solving this problem relating to trigonometry is number one, we want to solve problems involving triangles through the use of sine, cosine and tangent ratio. We want to be able to solve practical problems using sine and tangent dimensions. But before we go into some basic challenges or issues regarding trigonometry, let's consider the terms and definitions we may likely come across. Basically, what is trigonometry? Trigonometry is the branch of mathematics that uses right-angled triangles to solve triangles or problem relating to triangles in mathematics. An angle, you should know that angle is formed when two lines meet at a point. And basically, how do we know that an object or a figure is a triangle? Triangles are plane shapes bounded by three lines segments or three sides or having three interior angles with sum. The sum of the interior angles of a triangle is always 180. It's equal to 180. So by the time you solve for example, consider this triangle now. This angle, adding them together should give you 180. Anything above or below 180 is incorrect by the time you solve everything out. So now trigonometry with respect to right angle triangle, trigonometry ratio with respect to right angle triangle. When solving trigonometry using trigonometry ratio, there is a rule, and the rule is called Pythagoras theorem, which states that in a right angle triangle, the square on the hypotenuse, the square of the hypotenuse is equal to the sum of the squares on the other two sides. It means that if for this triangle now, the hypotenuse, which is always the longest side, is always the longest side of the three sides in the triangle, AC is the hypotenuse. So Pythagoras theorem is stating that in a right angle triangle, you can only solve problem involving triangles using Pythagoras theorem only if the triangle is a right angle triangle. Basically, it means that you can only solve problems using Pythagoras theorem if that problems involves a right angled triangle. And Pythagoras theorem states that the square of hypotenuse, this AC, is equal to the sum. By the time you sum this side, this AB and BC on the other two sides, if you sum them together, you should have the square of hypotenuse. That is the rules. It shows the relationship. Pythagoras theorem shows the relationship between areas of squares on the sides of a right angled triangle. So let's consider this triangle now. As I said earlier, I said AC is what? Hypotenuse side, which is the longest. Now we have AB. AB is opposite side if the reference angle is what? Is C. If the angle we are considering of this right angle triangle is C, then AB will be the what? Will be the opposite. Will be the opposite of this angle. Do you get that now? At a point, this AB will change to another thing. Now let's see. Opposite side, AB will be opposite side if the reference angle, which is the reference angle C, which is reference angle C, which is having the value Y of angle, will be opposite side. But if the reference angle is now on A, now if the angle is now on A, which is on this X, then it becomes the what? the adjacent. Do you get it now? Because it will be the adjacent, because this BC will now turn to what? Will now be the only side facing this reference angle. Then this side will now be the adjacent. Do you get that now? So BC for now, BC adjacent is an adjacent side. It's an adjacent side because the our reference angle is what? Is C. You can see for reference angle to be C, then this side will be the adjacent side and this side will be what? The opposite. But if our reference angle is A, then our opposite side will be BC, while our adjacent will now be AB. So that's that about that. So please take note of that. There is no more issue. You should know that this side is what? Is angle 90. So if this is angle 90, it's the right angle. This is the right angle. It's the right angle. So if this is angle, this is a right angle which has a value of 90 degree, which has a value of 90 degree. The other two sides should give you what? 90 degree. The other by their division or anything, it should give you 90 degree. So that by the time you add everything together within the interior angle, it's supposed to sum up to what? 180. So let's go into this problem. Now, for Pythagoras theorem, consider this angle, consider this triangle now. I said AC for Pythagoras theorem. AC, abi, this AC is the what? Is the hypotenuse, which is what? The longest side. AC square will be equal to what? AB square plus BC square. That is that. Please take note of that. This is the what? Is the hypotenuse. This is the adjacent, and this is the opposite. This now depends on what? This now depends on the reference angle. But using Pythagoras theorem, what you are to know is just to get what? Using Pythagoras theorem to get the length of the sides. You are using Pythagoras theorem to get the length of the side. For example, this AB is given up to us. AB is given to us to be 2 cm. AC is given to us to be what? 4 cm. We don't know the sides of BC. We don't know the side, the value of BC, the length of side BC. We don't know. Using Pythagoras theorem, we can get the remaining or the other length, the value of that length. So let's talk about those ratio, the sine ratio, the tangent ratio, and the cosine ratio. The sine ratio, the tangent ratio, because I want us to consider the two because they are interwoven. Like sometimes you may be given a question that depends on cosine, but at the same time, if you don't get the Pythagoras, if you don't use Pythagoras theorem or Pythagoras rule, you may be unable to solve the real question. So that's why they are what you must know when you are solving Pythagoras theorem. Pythagoras theorem, you are using it to get the sides of what? The size of the value of the sides of in that triangle, while you are using sine. So most of the time when you are using the sine ratio, cosine ratio, and tangent ratio to get the angle within the right angled triangle. So by the time we are moving, you will understand better. But basically, I want you to take note of this. Sine x, if angle x is the reference angle, can this sine x? If x is the reference angle, then we have opposite over hypotenuse. Opposite over hypotenuse. Do you get now? Opposite over hypotenuse. If the reference angle is x, that means opposite over. That will be opposite over hypotenuse. And what is our opposite? If our reference angle is x, our opposite will be what? BC. Our opposite will be what? BC. So our hypotenuse will now be what? Our hypotenuse is always sacrosanct. That means it's fixed. Do you get it now? So first of all, in the right angle triangle, you should first of all know which side is what is the longest. That's your hypotenuse. Then you now begin to use reference angle to get which of these other two sides is the opposite and the adjacent. Do you understand? So for our opposite here, for this triangle, our opposite is BC with reference angle X, while our hypotenuse is what? Is AC. Hypotenuse is AC. So when if we consider cos S, cosine, yes, now if we are considering, don't forget our reference angle is X. So for the cosine ratio is what? Cosine ratio is what? Adjacent side over what? Hypotenuse. So from this triangle, since our reference angle is X, then our adjacent will now be what? Our adjacent will now be AB. Our adjacent will now be AB over hypotenuse, which is what? AC. And for tan also, the tangent ratio is opposite over adjacent, which shows that our opposite is what? Our opposite is BC, while our adjacent side is what? Is AB. Do you get now? All these things depends solely on the reference angle. You will see that by the time you change the reference angle from X to Y, it will change the naming of each of those sides. Do you understand now? But you are to consider the other two angles, which is X and Y. This one is sacrosanct. This angle 90, angle at B, is sacrosanct. So you don't use that as a reference. You only use the two remaining sides as reference. So this is figure 1. This is figure 1, as we've been saying. From figure 1, reference angle A. You will see that our reference angle is A, which is angle X. Do you get now? So they don't ask us to find sine X. They ask us to find sine X. For us to find sine X, we need what? Opposite side, which is what? Opposite side is BC. And BC is unknown. BC is unknown. You can see BC is unknown. But we need it for us to be able to find sine X. Do you get now? And of course, we need hypotenuse side. It's being given, which is what? 4. It's being given, which is 4 centimeter. So our opposite side is BC. We don't know it. Our hypotenuse side is what? AC, which is 4. That is good. So BC is unknown. The first thing we should do is to what? Find BC using the Pythagoras theorem. That was why I was saying that you will definitely need to understand using Pythagoras theorem, the rules and why and reason for us to consider Pythagoras theorem. Do you understand now? Now you see that we are only what? To find sine X. But in the course of looking for sine X, there is one side that is unknown, that is peculiar to solving that problem given to us. And we can only solve that side using what? Pythagoras theorem, based on the question given to us. So how do we do that? We know that using Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares on the other two sides. Do you understand now? So since our AC from this now, our AC is what? Is the hypotenuse. Our AB is what? Our AB is the adjacent, while our BC is the opposite. So how do we go about it? What's the value of AC? Our AC is 4, so we have 4 square. Our AB is 2, we have 2 square. Our BC is unknown. So by the time you solve it, 4 times 4 will give you 16. 2 times 2 will give you 4 plus BC. So making BC the subject of the formula, we have this move to this side. When positive crosses equality sign, it becomes negative. So 16 minus 4, then we have what? We have BC to be what? Equals to 12. Now there are 2 ways for us to solve this problem. You can solve it directly, or you solve it using what we call the sword. Using sword, maybe if you don't understand sword, there is another video that we talk about that talks about sword and using indices and some other things to solve problem. Now let's look into this. So we have BC is equal to square. Don't forget, this is BC square, not BC. So you have to take square of both sides for us to be able to solve it. So we break it down. 4 times 3 will give us 12. Then we take the square root of both sides. The square root here, we cut this one. Then we are left with what? BC. Why this one is being squared? So we separate it according to the rules. Then we have 4 root 4 times root 3. Then we have BC, which is, when you solve this, root 4 will give you what? That is square root of what? Square root of 4 will give you 2, and this will remain. You get it now? 3. Or you solve directly, you just what? You just take the square root, of 12, and you have 3.464. So conclusively, BC, this side, will be what? Value is what? 3.464. So it could be this, depend on the question given to you. They may ask you to leave your answer in short form, or they may ask you to leave they may not ask you. So if they don't ask you, you can leave your answer in decimal. Don't forget that the real question we are solving is for us to find sine x. So, but because we need BC, sine BC from a triangle given to us, for us to be able to solve sine x, which BC is the opposite side, then definitely that's why we have to find BC first. Now let's go into the ratio sine x is equal to BC over AC. We have gotten the value for our BC, which is what? 2 root 3, and our AC, which is the hypotenuse, is 4. So if you have this 1, 2 in 2, 1, 2 in 4, 2, then you have root 3, then you have root 3 over 2. You get now. But if you use the direct value, which is 3.464 centimeter, you should have 3.464 divided by 4, which will give you 0.866. So either of the two is what is the value, or is the value for sine, is the value for sine x, is the value for sine x, is the value for sine x. So now I deliberately solve further so that we should cover this side at once. To get the value of x, if sine x is equal to 0.866. Now if you want to get the value of x, don't forget we only got the value for sine x, but for you to get the value of x, which tells us the angle, this angle x, which will tell us the real angle, the value for this angle x, then we have sine x is 0.866, then x will be at sine 0.866. Then you have the value for x to be what? 59.9 degree. Approximately the value of angle x on A is what? 60 degree. So now consider this figure again. We have gotten, I told you that this angle on the right angled triangle should be 180. One of the sides will be what? 90 degree, while the other sides will be giving value according to their angles. Now if we have angle B to be 90 and we have gotten our x, the x here to be 60, what do you think we should do in order for us to solve, in order for us to get y? Don't forget the total angle here should be what? 180. You can try that now. Okay, now let's go. If you have been given two sides, two angles of the three angles, then it's easy to choose. What you need to do is, from figure 1, since angle B is 90 and angle A is 60, then the sum of the angles in a triangle, should be what? Should be 180. So add the angles together. A plus B plus C is equal to 180. Our A is 60, our B is 90, and C, which is the unknown. So if you add 60 plus 90, we give you 150 plus C is equal to 180. Then make C the solid formula. You have 180 minus 150, then C will be what? 30 degrees. So the value for that angle C will be what? 30 degree. By the time you add everything together, it should not be less or more greater than 180. If you add 90 plus 60 plus 30, it should give you 180 degree. That's the total angle. So with this, we have come to the end of today's class. So we shall solve further some questions, practical problems where you use sine, cosine, tangent ratio to solve real life problem. Stay blessed. Bye.